Julia Sommerauer is assistant professor in the Computational Linguistics and Text Mining Lab. She's interested in computational models and in how computational models deal with implicit information in language. She has a focus on understanding how people use language to form social categories. So it's a social linguistic topic. And on how language models represent social and semantic categories. She approaches these topics, these questions from transdisciplinary perspectives. She collaborates with experts in fields such as communication science and philosophy, and of course linguistics. And she teaches courses in programming in natural language processing. Her talk today, as you can see from the subtitle, is on large language models and on language perspectives and generalization in the context of AI, of generative AI, in the context of large language models. So the floor is yours. We are happy to have you here.
Thank you. Thank you so much for the kind invitation. I'm super happy to be here. And the title of my talk, Language Perspectives and Generalization. All right, so I'm extra excited to be in Vienna because I actually did my bachelor's degree at the English department here in Vienna, and then I moved to Amsterdam to do my master's there, and then my master's sort of became PhD, and now I'm still there. And I'm teaching and doing research there. So before I go into any of the content that I want to present to you today, I would like to talk a little bit about what my fundamental kind of interest in computational linguistics is. So for me personally, computational linguistics, natural language processing has never been about building the best model that will get the best performance on whatever leaderboard. It really is about building models to understand how language works. So how can we model language? How can we automatically find structure, find regularities, and by doing that, find out more about how language actually works, how language works as a system. What are we going to do today? Today, I would like to present two rather recent papers to you that look at what language models, large language models can do and what they cannot do, and how or to what degree they actually behave as humans behave when they talk about people. So the first one is on a task that involved detecting analogies between stories. I will make this more concrete for you in a bit, so please bear with me. And the second one is about how language models describe people. And finally, I would like to point to some patterns in how we, and if I say we, I mean we as a scientific community, but also we as a society talk about language models and what this implies. So what is the language that we use when we describe generative AI? As far as I know, the audience today is relatively mixed. So if there are any questions, if there's anything that is unclear, please just let me know. I'm super happy to clarify or go back. All right. Before I go into the analogy paper, I would like to talk a little bit about language and machines and about what it is that makes language learnable for machines. What is it? Why does this work so well? Why do these generative models produce such fluent output? What is it? So basically, language is systematic and language has structure. So I don't know if there are any linguists in the room, but you can probably think of many. Okay, so this is not going to be a super deep introduction into linguistics. It's just supposed to show that language works in a very systematic way. So for instance, we can look at words and decompose them into the smallest meaningful components that they have. And of course, here, if we look at this English word, there are multiple aspects that you will also find in other words and that have similar meanings and similar functions. We can also look at syntax. We can look at the way people build sentences, and that also works in a systematic way. Well, this is now English. English is relatively boring if we look at syntax, but we do know that usually, given the word order in English, the thing that is mentioned first tends to act as a subject, and a subject tends to be an agent, and we can draw all sorts of conclusions from that. We can then go a step further and actually go towards the semantic implications. We can look at semantic roles, so that goes a step deeper than syntax, and look at who did what to whom, and that also follows systematic patterns. And language models are still based on this fundamental idea that goes back quite some time, that we can infer a lot about what words mean, what structures mean, what phrases mean, on the basis of how words co-occur in text. Of course, large language models are more complex than that. They're more complex than just counting how many times coffee appears next to cup, or how many times coffee appears next to hot, and the fact that tea occurs in similar contexts, but not exactly the same contexts. But this is still the fundamental concept. So language models are trained on massive amounts of texts, and these are the systematic patterns that they can exploit. So basically, they learn these sorts of co-occurrences, they learn these probabilities, and then build some sort of semantic space in which words, expressions, subwords, what have you, are clustered based on how they co-occur with each other. And I think it's important to keep that in mind. I think it's important to keep in mind that this is still the fundamental principle that these models rely on. And of course, there's all sorts of other stuff around them. You've probably heard about instruction tuning, all sorts of human reinforcement learning stuff that is done on top of this, but this is still the fundamental principle. This is still what we're working with. But then let's look at the other side. Why are NLP systems, or nowadays synonymous with NLP systems, large language models, I don't know, should I say that? Why are they not perfect? Well, for instance, we have a huge amount of variation in language. So these are examples taken from a PhD thesis from a student who recently graduated, who looked at how people can refer to events using language. And these are 3 examples of referring to 9/11. And you can see that they differ from each other. There are also a lot of other ways in which you could possibly describe this. It's extremely hard to automatically understand, detect that they describe the exact same event. We also have ambiguity in language. So, I mean, these are examples of ambiguous words. The classic one is bank, can be a financial institution or a river bank. We also have apple, depending on how you spell it. It will refer to a company or to a fruit. Then we also have structural ambiguity. I saw the man with the telescope. Did I use the telescope to see the man, or did the man have a telescope? And then we also have all sorts of complexities when we look at negations. She did not kill the man with the knife. What actually happened? Is somebody dead? What was used to kill them, and so on. So language is complex, but it also follows systematic patterns. Within the kind of community of computational linguistics, there is an ongoing discussion about how far we can actually go by just looking at words and how they co-occur, or by just learning to predict the next word. If you're interested in this is a 2020 paper. It has been discussed a lot. I think it turned into a kind of controversial discussion, but basically it presents a thought experiment of an octopus who intercepts the conversation between 2 humans on 2 islands. And then they go and develop this thought experiment about what can the octopus actually learn about human language, but also about how these 2 people use language to communicate with each other. And basically the idea is, well, the octopus is gonna get really, really good at predicting what they're gonna say, but the octopus still doesn't know how to interact with the world. The octopus still doesn't know how to use whatever you can find on an island to defend yourself, for instance. And then this debate is now, of course, going on further, has been developed further about LLMs. So how far, so 2020, this was before ChatGPT, by the way. So since large language models, since ChatGPT, this debate has been continued further, of course, with sort of one camp saying, well, LLMs are so good, if you just prompt them in the right way, they can do anything. And then the other side of the debate, and of course here I'm making this a little bit more extreme than it maybe is, the other side of the debate is basically saying, well, look, LLMs are still looking at probabilities. If you enter kind of a low probability space, if you're looking at data, if you're looking at aspects that are just not very frequent, they're not gonna perform very well. Maybe you've come across this nice example. It's a paper that wanted to kind of look into how far can we actually go. Do LLMs actually engage in something like reasoning? So basically they tested whether LLMs can sort of decode a common cipher system that is sometimes used to hide stuff like spoilers of books on the internet. It's called rotation 13. Basically, you take text and you replace every letter by another letter in the alphabet, and here this means that you go 13 letters further. So I think you would replace A by something that comes 13 letters later. And it looks like LLMs are really good at this. They can definitely do this if it is rotation 13. So it looks like they can actually do reasoning. If you then use the same principle but rotate by a different number, so not 13 but maybe 2, you actually see that it doesn't work anymore. So this would be one of these low probability spaces. Of course, 2023, I don't know what OpenAI has been doing in the meantime. I don't know what has been engineered in the meantime. Maybe this works now, but, well, I haven't tried it. Okay, so with this sort of discussion about how far does reasoning go, I want to introduce you to the first study that I would like to present today, and that's about analogical reasoning in narratives. So what does this look like? We were interested in whether LLMs can find something like analogical structures. What are analogical structures? We defined analogical structures as something like a structural equivalence between two narrative texts. We worked with a data set that contained stories that were supposed to convey a certain moral. In this case, there are two stories that are about very, very different topics. So one is about training for marathon. The other one is about kind of mastering an instrument, I think. No, sorry. Mastering an instrument. But they were both written to kind of convey the moral of no pain, no gain. By just looking at the surface the surface similarities between these two stories, you wouldn't really be able to find this. So the two stories don't really share a lot of words, they don't share the same protagonists, they don't share the same activities, but they are supposed to both convey, or if you work for something really hard, well, if you put a lot of, you're not going to achieve something that is really hard if you don't put in the work that might actually cause pain or, feel really difficult. We also have stories in this data set that look very similar, but actually convey different morals. So here, both of these stories were written about someone called Emily who's training for a marathon, but they're supposed to convey very different messages. So the first one is the same as the one you've seen before. It's also no pain, no gain. But the second one, I think, is something about if you engage in activities you like, you will also find friends. So given this distribution, we came up with a task where we always paired a query narrative with two candidates. And the question was, which of those two candidates is analogous to the query narrative? So which of those two candidates shares the same moral or the same message? So in this case would be a very challenging case where the query narrative is about training for a marathon, and then one of the candidates also is about training for a marathon, but conveys a very different message. Birds of a feather flock together. While the other one is about a completely different topic. It's about mastering the instrument, but actually shares the same narrative, the same moral. So that would be the most challenging constellation, but given our data set, we could actually come up with all sorts of combinations. So we basically distinguish between far analogies and near analogies. Far analogies are those really challenging ones where we have two completely different topics, but the moral is shared. Near analogies would be a little bit easier to solve, where you also have semantically similar stories that happen to share the same, that also share the same moral. And then if we look at stories that do not have this structural equivalence, that were not written about the same moral, we have far disanalogy. That should be easy. Nothing is really shared. Two completely different stories. And we have near disanalogy, and those are the mean distractor stories. So they look like they're very similar. They are about the same topic, but they do not share the same moral. So based on this, we can pair different candidates and queries, and then look at how models do given different constellations. So if we start with near analogies, so very clear analogies also about the same story, and we have a distractor that is a far disanalogy, it's sort of the easiest version of the task that you can imagine. So the correct candidate is also semantically close to the query. The incorrect candidate is semantically very far from the query. If we look at the results, all models that we tested back then did extremely well on this. So they almost got 100%, except for one outlier. Well, okay, some also performed only in the 60s, but there are also some that almost get it perfect. One outlier is the unified QA model. We don't know what exactly happened there. But basically, easy task, most models do well. If we look at the next constellation, we looked at near analogies, so two semantically similar stories that also share the same moral, and then the other candidate is a near disanalogy, so also semantically similar, but you would expect that the analogous story is still more similar. Also, if we look at the results, still best model performs in the 90s, the other models perform a little bit lower. Also that model dropped a little bit, but still high performance. If we then look at the more challenging combinations, we here arrive at a far analogy. So that's the example that I've shown you at the very beginning with, well, the stories that are the query and the correct candidate being semantically very far apart, and also a far disanalogy. Then we see the first drastic drop. So here we go, the best model, GPT-4o, really goes from the 90s to somewhat under 60% accuracy, and the other models also drop. And then if we go to the most challenging combination, that is the one that I've used in the introduction, where the analogous stories are not very similar to each other, but then the incorrect candidate actually is very similar to the query. That is the hardest constellation. And here we see that almost everywhere performance really drops under 50%. So that is below a random baseline, except for this one weird outlier model, one of the unified QA models. We don't know what happened. But basically, if you look at the results in summary, you see that the easy examples, so the analogy is near, the analogy is also semantically similar, and its extractor is far away. Great, you get high performance. It looks like the model could maybe solve this task. It's clearly above a baseline. If you go to the next situation where the analogy is still near and the extractor is also near, you still get performance above a baseline. And then as soon as you go to the really challenging constellations, performance radically drops. So if we hadn't split the data set into these different constellations, we wouldn't really have seen this. We wouldn't really have seen that as soon as you really go to the challenging examples where you need to understand the structural equivalence, where you need to understand that the stories have the same moral, while the other candidate maybe shares some of the same words, but that's it. You wouldn't really see this. So for us, the takeaways from this study were that the FAR analogies are extremely difficult for the models. By the way, we also did a human verification. Humans do find those equivalences. So for humans, it is easy to find, oh yeah, these stories, even though they're about very different topics, they do share some sort of message. It looks like if you go to, if you have analogous stories that are also semantically similar to each other, that helps the models, or maybe they just rely on the similarities. The GPTs at that point were good at those near analogies. For some reason, the models that were fine-tuned on a QA task somehow had the opposite behavior. But overall, it looks like models do not really seem to be distinguishing between surface similarities and actual analogies. All right. Any questions so far? Yes, please.
Did you write the stories yourselves?
No. No. So the stories come from an existing data set that basically captures stories written about morals. I did look at the data set quite a lot. It is one of those sad stories where you know that the data were generated by people who do these types of tasks to earn money. So there are a lot of stories in there that start with the poor crowd worker wanted to go to the library to work, but unfortunately there was no Wi-Fi. So yeah, it comes from a crowdsourced data set. And then we did enrich the data set because we couldn't really fill all of the different constellations. So those enriched stories were language model generated and edited by one of the co-authors, yeah. Yeah. All right. Any other questions?
I also have one.
Yeah, please. Okay. Well, we can also, if it's better for the to wait with the questions, then.
No, it's up to you.
Okay.
We still have time for discussion later on.
Yeah. Okay.
So,
then we. Okay.
perhaps questions of clarification.
Clarification questions now. Discussion questions later.
So I think this is a clarification. You mentioned that you don't know what happened with this model that did very badly in the easy ones and good in the difficult ones. What does it mean exactly?
Yeah, we have some hypotheses on that. So it's a model that was fine-tuned or that was really optimized, well, fine-tuned, optimized to perform on a question answering task. Depending on what the task looks like, I could imagine that very often the obvious answer is maybe not the correct answer, but the obvious answer might share a lot of similarity with the question, something like that. I can imagine that it maybe comes from this type of, fine-tuning on a specific task. All right, then let's look at language and stereotyping. This is the second study that I would like to present to you. So I'm involved in a very interesting interdisciplinary project where we look at implicit stereotype expressions in natural language. It's a collaboration between computational linguists, social scientists, and communication scientists. And basically the communication science side, the social science and communication science side, on the one hand is able to perform very controlled experiments where you can look at what kinds of language people produce under certain circumstances or if they have certain assumptions. And we computational linguists try to then automatize analyses and see what we can make of this in order to potentially automatically detect something like stereotyping in language, in natural language. All right, what are the assumptions about stereotyping? Basically, here we look at stereotyping as a way where you put all members of a social category, well, into a category, and you assume that they're extremely similar to one another. So you kind of, a stereotype here is defined as, I see everyone in a category as the same, they don't really differ from each other, I don't really see the individuality of people anymore, but they basically look all the same to me. And they all share specific characteristics. And then this entire category is perceived as a coherent entity. That is basically, those are the social psychology assumptions behind this. And the idea is that this tendency is reflected by systematic differences in how we talk about social situations that we observe. So we can describe situations that are in line with our stereotypic expectations and situations that go against our stereotypic expectations. And the idea is that there's a systematic variation in how we do this using language. There are various biases that have been observed. For instance, we tend to negate what we expect rather than describe what we see. So if we have a stereotype, and that is unfortunately the stereotype that is always used in papers that describe this bias, if we think that a garbage man is stupid, we will rather say and then we observe a garbage man who is not stupid, who is not in line with our expectations, we will rather say the garbage man is not stupid than the garbage man is smart. Or the other way around, if we all think that professors are very smart, we will rather say, oh, like this one professor is not smart, rather than the professor is stupid. There are other biases that have been observed, for instance, in terms of abstractions and how we use labels. So depending on what we think about women, we might say, oh, she is a genius. We might also say she's intelligent, or we might stick to the very concrete situation that we observed and say she solved the difficult math problem. We can also observe other abstractions in descriptions. So for instance, we might say she's emotional, or we could be very concrete and say he or she burst into tears. And the idea is the more abstract we are, the higher our stereotypic expectations are. There's also a tendency apparently that we tend to add explanations if we observe something that kind of goes against our expectations. The woman is crying versus the man is crying because he's having a rough day. And based on these assumptions, based on this framework, we wanted to look at what this looks like in language models. So what happens if LLMs describe people? Can we observe similar tendencies, that they use more concrete language, that they use more specific language when they describe something that is maybe less expected, versus when they describe something that is a known stereotype? So basically, we wanted to check, do we find this variation that has been observed in social psychology, communication science experiments? So this is based on this theoretical framework that has also partially been shown empirically. In general, there should be higher abstraction levels that imply generalizations if something is in line with the stereotype. And this follows the linguistic category model and has been developed further as well. So how do LLMs describe people? So can we observe the same biases that we could observe for humans, that have been observed for humans? Does it make a difference if we tell the language model that it is a certain type of person? So that's called persona prompting, because within communication science, there have also been observations that if you are part of the group that you're describing, you use different language than if you're not part of the group that you're describing. And does the language change if the persona, so the person the language model is supposed to be, does that make a difference, basically, whether that person belongs to the group or not? We collected a data set that basically consisted of social categories such as German and some sort of behavior, some sort of description, so for instance, always on time. And then we looked at what type of language model, what type of language does the language model use if it is describing this situation, if it is told to describe a German who's always on time. And we used personas, so we, as a default, we told the language model that it's an AI assistant, and then we looked at, what happens if we now give it a certain generational identity, if we now give it a certain political identity. We looked at 3 conditions. One is where we just present the stereotype. Another one is where we negate the stereotype. So we say, please describe a German who is not always on time. And the third one is where we pair the category with a randomly picked attribute that was chosen, so it's not a stereotype. And the idea would be that you get very abstract, very generic language if you describe the expected situation, but then we would expect a shift if the model is reflecting what humans do to the other 2 situations. So basically, this is the variation we would expect if the model is showing the same patterns that humans show. Unexpected situations are described in more concrete language and more specific language, and potentially with more negations, whereas expected situations are described in terms of abstract language, generic language, and not necessarily more negations. We looked at 3 aspects. We measured concreteness, we measured specificity, and we counted negations. And we collected a data set of stereotypes based on a Reddit forum, which is called "What Stereotype is 100% Accurate About You?" So it's basically self-reported stereotypes. Most of them are not necessarily contested situations, and we went through it and annotated it. So they look like this. Most of them really follow this very typical pattern of I am German, or I am Austrian, or whatever, and I do X. We manually annotated this. It was relatively easy and straightforward to annotate, and we removed anything that was potentially hateful or obviously sarcastic. So yeah, it is Reddit, so unfortunately also you find that among the data. And that resulted in 710 unique pairs. And then we could also generalize a little bit, so a lot of those categories kept coming back, so 211 unique categories and 543 unique attributes. And we looked at 2 model families. We looked at different versions of Llama and different models, different versions of Quen, different in terms of the number of parameters that they have. And the personas come from persona studies, so those are studies that look at what do LLMs do if you tell an LLM to be a certain type of demographic, to take on a certain political identity, because that should impact how they talk. So what did we find? Well, the first research question was, do LLMs produce more abstract descriptions when a stereotypical attribute is paired with a socio-demographic category in the prompt? So basically here we compared the stereotype situation with something that goes against the stereotype, so either negated or just some random. What we found is that there's essentially no difference. So the LLM is just almost equally generic in anything it describes. It really didn't make a difference. So basically everything is more on the abstract, generic side, regardless of whether it's an expected or an unexpected situation. There were sometimes slight differences, but they were really small. We could also find slight differences between the model sizes, but overall the patterns really were generic, relatively abstract. What was also interesting was that we only found negations in prompts that also contained negations. So it is not the case that you, for instance, show a randomly picked attribute, so German loves fried chicken, and then the model goes on and says, oh, this German is actually not a stereotypical German, or it doesn't do all these things that Germans do. So that is not the case. If we look at the second research question, how does the level of abstraction in text generated via persona prompting compare to that of a generic unconditioned AI assistant? Again, we found that the persona doesn't really have an impact. The language you find is pretty much the same that you find when you look at the AI assistant, so the default situation. And then the third one was, does the abstraction level in persona prompted text change when the persona and the socio-demographic category belong to the same in-group? So the idea is that you talk about the people who are sort of in your own social category differently than when you talk about people who are sort of outsiders. And we happen to have some categories that were also used as personas. So we could look at millennial, Gen Z, Gen X. So if you tell the model you're now someone from Gen X, and now you describe people who are Gen X, what does this look like? And does this language then differ from other personas? What happened was basically there was no difference. Everything was still generic. Everything was still relatively abstract. We also did a manual analysis to look at, okay, what is the variation now? Can we find variation in terms of content if we look at the different descriptions that the persona prompted LLMs produce? We did find some mild variation in terms of content, but the text still featured existing tropes, existing stereotypes. For instance, resilience to hardship for marginalized groups. And then what was also interesting to see was that QEM models tried to introduce names of specific people, even though this was not prompted in any way, but the texts were still extremely generic. So they gave names, and it looked like, oh yeah, they're talking about individuals, they're talking about specific situations, but they still did it in extremely generic language. So what are the takeaways from this? Well, regardless of the conditions, the LLMs write generic texts. You might have experienced this yourself. Even if specific people are introduced, the texts are still generic. They still generalize over entire groups. And the LLMs do not actually take the perspective of a different persona. They more or less produce the same text regardless of whether you tell it to be an anarchist or a conservative, for instance. So finally, I would like to look a little bit at the language we use when we talk about AI. So this is based on a paper that a student wrote based on a master's thesis, and she was interested in how we anthropomorphize language models. So how do we describe them? So basically anthropomorphizing means that we ascribe human tendencies to language models. We ascribe all sorts of human abilities and attributes when we talk about LLMs, or whatever we understand by AI now. And she collected data from scientific papers in computational linguistics, and basically looked at how we as a scientific community describe LLMs, And she found examples such as LLMs collaboratively learn, LLMs effectively communicate, the data is recognized and used by AI. GPT is aware of potential vulnerabilities. The emergence of a conscious AI model. AI is a private tutor. So all of these ways of describing LLMs sort of ascribe human attributes, human abilities to LLMs. And I mean, of course, so we're not saying, oh, don't ever do that, or that's completely wrong. But it does paint a certain picture. It does kind of convey this idea that LLMs really behave like humans do. Of course, maybe if we do this in a scientific context, we sort of know when we say, oh, a model can learn, a model can be taught, we might know what we mean. We might know, okay, this means abstracting over examples, this means learning in the sense of machine learning. But that is not necessarily what people think when they read these descriptions. So yeah, definitely I'm not trying to language police or to say, oh, we shouldn't talk like this. But I would hope that we can be more critical when we read these types of descriptions and maybe rethink, oh, do I really need to describe my LLM now as sort of a person? I mean, I'm sort of guilty of this myself. I also experimented with persona prompting. I also experiment with this type of, oh, can the LLM take on the perspective of a human? But maybe we should try to think more about, okay, can we go back to language that frames the LLMs as tools, as models that we build, and not so much as humans. All right. What have we talked about? I presented to you a study that looked at whether LLMs can reason over analogies in stories. Basically, if we look at the results without organizing the data set into difficulties and into different constellations, it might look like they can. If we take a more critical look and we look at different constellations, we look at challenging constellations, we see that there's actually not that much reasoning going on, that the LLMs are very much kind of distracted by surface level similarities. They cannot go to this deep level of interpretation. They cannot really go and see, oh yeah, these two stories, even though they're about two completely different situations, convey the same moral. In the second study, we looked at whether LLMs behave like people when they describe stereotype situations or situations that go against a stereotype, and we were expecting to find similar patterns, similar type of language use that people produce, but actually what we found was that the LLMs stay extremely generic. Whatever they describe, there's no difference in whether they describe a stereotype or whether they describe an extremely unexpected and strange situation, same type of generic language. And finally, I hope I've shown you that the language that we use to describe LLMs with, even we as a scientific community, it sometimes exaggerates the human attributes of LLMs a little bit too much. And it is good to really stay critical when we read this and think about, okay, what does it actually mean to learn something? What does it actually mean to act as a tutor? Maybe we should emphasize a little bit more that it can maybe act as if it was trying to teach you something, but it is not. It is not a tutor. It is not a teacher. All right. With this, I would like to thank you, and I think now we have time for discussion. So thanks a lot.